Hello all, I am V. Koteswara, Assistant Professor, Department of ECE, Marri Laxman Reddy Institute of Technology and Management. I am going to give you a lecture on microprocessor and microcontroller. So these are the topics I am going to explain. Course objectives, introduction, architecture of 8086, features of 8086, register organization of 8086. So these are the topics I am going to explain. Course objectives. To understand the architecture of microprocessor and can gain the knowledge about programming of microprocessors and microcontrollers and study the architecture of microcontroller and programming of various applications. The next objective is learn about interfacing devices and interfacing techniques. And the last objective is understand the basic concepts of ARM processor. Introduction. So here, what is microprocessor and what is microcontroller? Microprocessor is a small CPU which is used to perform arithmetic and logical operations. And the one more definition for microprocessor is microprocessor is a programmable logic device. It accepts the data from memory, processes that data and gives the result as output. So these are the definitions of microprocessor. And microprocessor contains millions of tiny components like transistors, resistors, diodes and etc. So next coming to block diagram. So this is the basic block diagram of microprocessor. So here microprocessor is a small CPU which is used to perform arithmetic and logical operations. So it consists of ALU, control unit, register, array. So main components present in microprocessor are ALU, control unit, register, array. So ALU stands for arithmetic and logical unit. So it is used to perform arithmetical and logical operations. In the name itself, arithmetic and logical operations. It is used to perform both arithmetic and logical operations. Next component is control unit. Control unit is used to control the instructions during the program execution. Next, third one is register array. Registers are used to store the temporary results. So different registers are available in 8086 and these are the main components. Next, input device and output device and memory. So these all are connected externally. So in microprocessor, input devices, output devices and memory, these all are connected externally. So whereas in microcontroller, CPU, input devices, output devices, memory, all are connected internally and fabricated on a single chip. That is called microcontroller. So that is the difference between microprocessor and microcontroller. Next topic is features of 8086. 8086 is a 16-bit microprocessor. It can transfer 16-bit data at a time and it is available as 40-pin IC dual in package. And the memory of 8086 is 1 MB, 1 megabyte. And it is having 20 address lines and 16 data lines. And the operating frequency of 8086 is 3 ranges are available based on the operating mode. So 8086 microprocessor, we can operate in two modes, minimum mode and maximum mode. Minimum mode means single processor, maximum mode means multi-processors. So based on the operating mode, we can use the frequency range. So 3 frequency ranges are available in 8086, 5 MHz, 8 MHz and 10 megahertz. Next, operating voltage. So 5 volts are required and memory size is 1 MB and instruction queue size is 6 bytes of instruction queue size. Okay, and these are the features of 8086. Architecture of 8086. Architecture mainly consists of two functional units. So here we can observe bus interface unit and execution unit. So this architecture mainly consists of two functional units, bus interface unit and execution unit. Two functional units are separated by dotted lines. So here in bus interface unit, it provides the all bus operations and it provides the address bus as well as data bus. And here adder circuit also is there. It provides this adder circuit. By using this adder circuit, we can calculate the physical address to transmit the data or to receive the data from memory to IO devices or IO devices to memory. So we can use physical address. The physical address is equal to segment address into 10H plus offset address. Next, coming to execution unit. Execution unit takes the instructions from instruction queue. Bus interface unit fetches the instructions from memory and stores in instruction queue. So as many as instructions it can fetch and store into queue. The size of queue is 6 bytes long. So execution unit takes the instructions from instruction queue and execute these instructions and store the result in registers. So the main linkage between bus interface unit and execution unit is instruction queue. The size of instruction queue is 6 bytes long. So bus interface unit can read the data from memory and can write the data into memory. And execution unit executes the instructions and stores the result in registers. Next one is register organization of 8086. Register organization of 8086. So we have total 14 16-bit registers and registers are categorized into three types. The first one is the general purpose registers. So we have four types of general purpose registers: AX, BX, CX and DX. So here, AX is a 16-bit register. AX is a 16-bit register. AX is a 16-bit register and also it contains two sub-registers. AX is equal to two sub-registers AH and AL. AH and AL. So these are the two 8-bit registers. AH means higher 8-bit data. AL means lower 8-bit data. So AX contains 16-bit data and the 16-bit data is divided into 8-bit, 8-bit, lower 8-bit data and higher 8-bit data. So suppose we can see how 16-bit data will stored in AX. So it will stored in bitwise. For example, AX is a 16-bit register. So I am taking that input as 1, 2, 3, 4. So 1 represents 4 bits. In hexadecimal, it represents in 4 bits. 1 means 0, 0, 0, 0, 1. 2 means 0, 0, 1, 0. Next 3 means 0, 0, double 1. And next 4 means 0, 1, double 0. So in binary data will be stored like this. This is the 16-bit data stored in AX register. So this is the 16-bit data. First 4 bits, next 4 bits, and third 4 bits, and fourth 4 bits. So total 16 bits. If we take data in decimal, it is converted into hexadecimal, and then hexadecimal data will be again converted into binary data. So binary data will be stored in the register AX. So AX is a 16-bit register. Next is register is BX. So BX is also called base register. It holds the address of the memory within the data segment. Next, it is also contains two sub-registers. BX is equal to 2 sub-registers. Similarly, AX, BX also having 2 sub-registers, BH and BL. BH and BL. Next register is CX register. CX is also a 16-bit register. It is also contains 2 sub-registers, CH and CL. CH and CL, lower 8-bit and higher 8-bit. So CX register used as counter register. It is used for loop operations, loop instructions it is using. Next one is the DX register. DX register is also called as data register. So it is the extension for AX and also holds the address of IO addresses. It holds the addresses of input and output. The next one is pointers and index registers. Pointers and index registers. The stack pointer. Stack pointer is used in stack segment. It is used during the instructions like push, pop, call and return instructions. Stack pointer used in stack segment, and instructions used for stack pointer is push, pop, call and return instructions. Push instruction is used to push the data from memory to top of the stack segment. Memory to stack segment. Push the data. Next, pop instructions. Pop instruction is used to retrieve the data from stack segment. Next, call instructions. Call instruction is used to call the subprogram. And the next one is return instruction. Return instruction is used to return back to main program. Next, base pointer. Base pointer can hold the offset address of any location within the data segment. Next one is the source index register. Source index register is used for string operations to store the input data. Next, destination index. It is also used for string operations. It holds the data extension of data segment. It holds the data in data extra segment. It is the extension for data segment. Segment registers. Next, third category is segment registers. So total memory of 1 MB is divided into 4 segments. Total memory is divided into 4 segments. So we have a 4 segment registers. Code segment register, data segment register, stack segment register and extra segment registers. So first one is code segment register. So it is a 16-bit register having the address of 64 KB, and it holds mainly it is used to store the program instructions. Code segment register is used to store the program instructions. The next one is stack segment register. It is also a 16-bit register. It is used to store the subprograms. Subprograms or subroutine. The next one is data segment. Data segment register is also a 16-bit register, address of 64 KB. It is used to store the program data, not the instructions. It is used to store the program data. The next one is extra segment register. It is also a 16-bit register having the address of 64 KB. It is used to store the program data, which is extension of data segment. And the last one is instruction pointer. It acts as a program counter in 8086. It holds the address of the next instruction which is going to be executed. So these are the different types of registers available in 8086. The next one is applications of 8086 microprocessor. Applications of 8086 microprocessor. So microprocessor is used for general purpose and microcontroller is used for application purpose. So main applications of microprocessor are, it is used in calculators, accounting system, games machine, and communication systems, military applications, and traffic control signals, and data acquisition systems, multi-user, multi-function environments. These are the general applications of 8086 microprocessor. So these are the textbooks for 8086 microprocessor, AKRA and Ayala for microcontrollers. Okay, thank you viewers.